So welcome to today's lesson. This is lesson 7 in your unit 3 to 4 book. It's the lesson for December 21st and 22nd. Right? So this is our warm-up right here, right? And this is 7.1 in your book. Right? So you may pause the video if you need to find it. But it says, here are the recorded temperatures at 3 different times on a winter evening, right? So at 4 p.m., it was 25 degrees Fahrenheit. At 6 p.m., it was 17 degrees Fahrenheit. And at 10 p.m., it was 8 degrees, right? Tyler says the temperature dropped faster between 4 and 6 p.m. And Mai says the temperature dropped faster between 6 p.m. and 10 p.m. Who do you agree with? And explain your reasoning. So this would be a good time for you to pause, think about it, write down some ideas, right? And then when you're ready, turn the video back on and we can discuss. Okay. So if we're just going to observe, I can observe that for Tyler, between 4 and 6, there was a decrease in the temperature, right? And that temperature decreased by 8 degrees, right? And for Mai, there was also a decrease in the temperature. And that decrease looked like it was it was 9 degrees, right? So you're just looking at the absolute value. They both decreased. How much did they decrease by? So some of you might argue, well, it looked like Mai had a bigger drop, right? Dropped by 9 degrees Celsius. This is talking about rate of change, okay? Related to slope, right? And so it's not just enough to look at the absolute value of how much it decreased. Like, okay, it decreased 8 degrees, it decreased 9 degrees. You've got to look at the time period, right? And these intervals are not the same, all right? So if you're talking about the rate of change, remember, rate of change is always going to be the change in y over the change in x. All right, now which is which, right? Remember, we always talk about how time seems to be the master of everything. Okay, the independent variable here, the temperature changes according to the time. So the independent variable is going to be x. The dependent variable is going to be the y. Right? So let's talk about the two different scenarios. All right. So there's Tyler, there's Mai. All right. So we're talking about change in time. I'm sorry, change in temperature over change in time. And that's really how we're going to figure out the average change over those time periods. All right. So, okay. For Tyler, it went from 4 to 6. All right. And then the temperature, okay, the change in temperature is going to be 17 minus 25. Right? So the temperature, the final temperature minus the initial temperature. All right. So this gives us, all right, when you do that, that gives you -8 over 2. So it did go down 2 degrees, but it did that over 2 hours, which means there was a drop of 4, decreased by 4 degrees per hour. All right, so a drop on 8 degrees over 2 hours is 4 degrees per hour. So really, that's what this means. That is the bottom line. Okay. Now let's look at the time interval for Maya. Okay. And for her, so that was between 10 and 6. Okay. And then at 10 o'clock, the temperature was 8. And at 6, it was 17. Okay, so 8 minus 17, that's going to give us, so that's -9. So it dropped 9 degrees in 4 hours, which means -9 divided by 4, right? That gives us 2 1/4. All right. So that means the temperature decreased by 2 1/4 degrees Fahrenheit every hour. So going back to your question, when did it drop faster? 4 degrees per hour or 2 right? So even though Maya's dropped more, if you're thinking about per hour, right? The decrease per hour was greater between 4 and 6, as Tyler said. Okay, let's take a look at the homework assignment. So that was pages 173 to 174. All right, so maximum height was right here, right? When the H was 4, okay? The minimum height was right here, okay? When H was 1.5. When the height stayed the same, it's between these two intervals, between 7 and 8. And we will talk more about that in the future. Okay. And then the starting height, where it was in the beginning at time 0. Right? Ooh, and my purple is gone. Oh. Okay. Would have been here. All right. So number 4, you were given equations. So really what you do is you substitute the given values for x. So f of 100 means in place of x in those equations, you put 100 or expressions and you evaluate the expressions. All right. Then you pick the largest number. So those, okay, were the results. You might need to pause the video a second so that you can look them over. And remember that these notes will also be posted online, so you could, look at them some more if you don't feel as though you've had enough time to do it here. And number 5, important, because remember, we spoke about function notation and that f of 2 does not mean 2f, right? So you can't add them like you would 2f plus 3f. And this right here is one of the reasons why. It's an explanation, it's an example of why you can't do that. Because f of 2, in this case, when f of x is x squared, would be 4. And f of 3 would be 9. 4 plus 9 is not 25, which is what f of 5 would be. So you can't just treat them like terms and add them. Okay, so let's start with today's assignment. It's 7.2. Okay. And I'm going to keep this large so that I don't have to go back and forth. I can see this graph. Okay. Alrighty. So it says the table and graphs show a more complete picture of the temperature changes in the same winter day. So they're talking about the same winter day with Tyler and Mai, right? The function T gives the temperature in degrees Fahrenheit, right? H hours since noon. That's important, right? H is the hours since noon. So let's look at this graph. That means, all right, 0 is noon. Okay? So H hours since noon. Okay. So it says, find the average rate for the following intervals and show your reasoning. All right. So between noon and 1 p.m., right? So the temperature at noon is here. Okay. Temperature at noon is here. The temperature at 1 is here. All right. Average rate of change doesn't just mean, well, this temperature is 18, because notice the interval is 2, and this right here is 19. So you're like, oh, it went up by 1 degree. Well, it did go up by 1 degree, but is that necessarily the rate of change? You won't know until you figure out how much time has passed. So you need to know the change in the time as well. All right. So to do this, we're going to do just like we did in the warm-up. You need the change in temperature, right, over the change in time. All right. And this is how you calculate average rate of change. Oh my gosh, I should have typed that. My apologies. All right, so average rate of change is change in temperature over change in time. All right, so let's look at this example that we have right here. All right, between noon and 1, all right, is a change of 1 hour, right? All right, so this is the temp. So Fahrenheit over hours is a change in 1 hour. The change in Fahrenheit is from 19 to 18, right? So what a coincidence. This is 1 over 1, which is 1, right? So that means the average rate of change is 1 degree Fahrenheit per hour. All right. Let's look between noon and 4 p.m. All right. So between noon and 4, that will give you, that's a change in 4 hours, right? And 25 to, right, from 18 to 25, that's going to give you a change, an increase of 7 hours. I mean, a 7 degrees Fahrenheit over 4 hours, right? So that would give you 1 3/4, which is 0.75, right? It's a 1 3/4 degree change per hour. All right. How about between noon and midnight? So noon, we already know is 18. Midnight looks like that's about 7. Yeah, that looks like it's about 7, right? So this is a decrease, right? If you look here, that is a decrease. All right. So the change in time is 12 hours. The change in temperature over that time, right? It was 7 at midnight. It had been 18 at noon. So that's a decrease of 11 degrees over 12 hours, right? So that's a little less than a decrease of 1 degree, okay, per hour. So 11 over 12, right, is about, we're going to approximate. So it's a decrease of 0.92 degrees Fahrenheit, right, per hour. So that's how you find rate of change. Okay, it's like finding slope. You need to figure out, okay, the dependent variable, how much it's changed over the change in time. All right, let's look at number 2. Oh, we already did number 2. Huh. All right, so we did number 2 already, right? We gave yes, we did number 2. Okay. Over what interval did the temperature decrease the most rapidly, right? So they're probably talking about 1 hour intervals, right? Mm-hmm. So when did it decrease the most rapidly? The biggest drop? Okay. To me, biggest drop looks like it's right here. Right? That's the steepest line. Okay. And the biggest increase, when I'm looking from hour to hour here. biggest increase looks like it's about from 3 to 4. Because remember, if you're talking about rate of change and how it's related to slope, right? We're talking about the steepness of a line, right? So the biggest drop to me would be the steepest line with a negative slope that connects 2 points, and the inverse for the increase. So here, I would say between 5 and 6. And here between 3 and 4. All right. Populations of 2 states. The graph shows the populations of California and Texas over time, right? So if you look at the key, you see that the blue solid line is California. The red dotted line is Texas, right? It says estimate the average rate of change. So once again, you see this, you know they're talking really about slope, right? Change in the dependent over the change in the independent. So in this case, the change in population over the change in a certain number of years, right? So between 1970 and estimate the average rate of change in the population in each state between 1970 and 2010, right? So let's do California. Oops. And Texas. Okay, so California between 1970. Whoops. So right here, 1970 looks like it's about, oh, that looks like 20 million people, right? In 2010, it's a little bit more than halfway. I don't know, probably about 37 million people, maybe. Right? You have some leeway there because it's not exactly exact, right? So we're looking for the change in population, right? So the average change is going to be equal to the change in population over the change in time, which in this case is measured in years. Okay, so for California, the change in population, so the year is 2010 minus 1970. That's a change of 40 years. Okay. And the population, so it went from, well, it was 37 million. Okay. In 2010, 20 million in 1970. So that's a change of 17 million over 40 years. Okay. So that's 17 million over 40 years. So 17 divided by 40. So that's 0.425, right? So what that really means is California saw an increase of 4.425 million, which is 425,000 people per year. Okay, that's what that really means. So how about Texas? Texas, over the same 40-year period, okay, so this is 1970. That looks like 12 million-ish, right? And is this halfway? I don't know. I'm going to call it halfway. So this looks like it's about 25, right? So it was 25 million in 2010, and it had been 12 million in 1970. So that's an increase of 13 million people over 40 years, right? Which, when you divide 13 by 40, is 0.325 million, which means that in Texas, there was an increase of 325,000 people per year. All right. B says, in this situation, what does rate of change mean? Oh, well, excuse me. We just talked about that, right? The rate of change means the change in population per year in each state. Right? Which state's population grew more quickly between 1900 and 2000? All right, so let's look. California in 1900 was right here. 2000, ooh, it's right here. Right? So when I look at that, I tell you, you could, ooh, okay. Texas, 1900, 2000. All right. So you could calculate it. I would say, based on the steepness of the line, right? It would definitely be California, right? But if you didn't want to do that, you could calculate it. They're both over 100 years, right? And Texas's population, so this looked like in 2000 it was 20 million people, and about 3 million. So that's a change of 17 million over 100 years. Whereas in California, the change was started off even less. So in California, it started off at maybe a million, right? Yeah, maybe a million, and then it ended up being about 33 million. So that would be a change of 32 million, 31 million over the same time period. So it's definitely California. All right. So let's do Texas and California. All right. We know the time period is over 100 years, right? 1900 to 2000, 100 years. So yeah, Texas looks like it went from about, I don't know, about 3 million to 20, right? So 20 minus 3, so it changed 17 million over 100 years, right? So, okay, that is 0.17, right? So 0.17 times a million. California went from about 1 million to about 33, right? So that's 32 million people over the same 100 years, right? So it's clear that California had the greatest rate of increase. But as I said, right, you could have, you know, surmised that by looking at the graph, seeing which one had a steeper slope, right? Because that would indicate the greater rate of change. Right, so you're going to practice on your own now. Okay. And start at page 180, numbers 1, 2, and 4, right? And then you could check the answer key online when you are done.